1.6, other types of equations and applications. So the first problem say to decide what values of the variable cannot possibly be solutions for each equation. So basically we're just seeing what solutions would cause a problem. So something like 12, we have 2 over x plus 1 plus 3 over 5x minus 2 is equal to 0. So things that cause a problem is anything that basically causes the denominator to be 0 and makes the equation undefined. So I'm going to set each denominator equal to 0 and solve, and those values are the ones that I'm looking for these problems. So we're not actually like solving these equations, we're just figuring out what would cause a problem. So x plus 1 is equal to 0, and 5x minus 2 is equal to 0. So then x is equal to negative 1, or 5x is equal to 2, so x is equal to 2 over 5. So these two numbers here would cause a problem if x is either of those values. So we can't, basically x can't be those values because it makes it undefined. Let's see, 14, 2 over x plus 3 minus 5 over x minus 1 is equal to negative 5 over x squared plus 2x minus 3. So just to be clear, I didn't just set them equal to 0 because this equation was equal to 0. I would do that regardless because the bottom can't be 0. So I'm trying to figure out what makes the bottom 0. So on this one, the first thing I want to do before I start setting things equal to 0 is I want to see if I can factor this denominator, because sometimes it works out nicely to where the denominator of this is actually these two things over here, and so just less work for me. So what would this denominator over here factor into? Negative 1 and 3, yep. So x minus 1 and x plus 3, which works out nicely to be these things over here. So I only need to do each of those one time. So then x plus 3 equals 0, x minus 1 equals 0. So if x is equal to negative 3 or x is equal to positive 1, we're going to have a problem. And it would cause a problem on the other side as well, which is why we only need to do it once. If this side over here had factored into something other than x plus 3 and x minus 1, then I would have needed to also solve those ones to figure out what else would have been a problem. But since it was the same, I didn't need to do it twice. We tracking so far? Okay. All right, let's see. The next thing say to solve each equation. So 18, we've got 4x plus 3 over 4 minus 2x over x plus 1 is equal to x. Any ideas how I would go about solving this? Or even if you don't know exactly how to solve it, like, what do you recognize that I would need to have to be able to solve it? Any ideas? If I wanted you to add those together, what would you tell me that I need to do to be able to do that?
Same denominator.
Yep, I would need the same denominator on both. But I don't really like to deal with fractions, and typically most of my students say they don't either. So I'm going to show you a lovely trick to get rid of them. So we put parentheses around the whole thing, and then whatever I have in the denominator of each one, I'm going to multiply the entire equation by that. Okay, and I'm going to eliminate the denominator entirely. So this is basically the exact same thing as if I got a common denominator. I just think it makes it easier, and I don't have to deal with fractions beyond this point right here. So when I multiply this first piece, so this 4x plus 3 over 4 times the 4 times x plus, times x plus 1, the 4's would cancel each other out. Okay, so the 4's would be gone. So then I'm going to have 4x plus 3 times x plus 1. Then I have minus. So now, for the second piece, I've got 2x over x plus 1 times 4 times x plus 1. So the x plus 1, I have that in the top and the bottom, so that goes away. So I would be left with 8x, so minus 8x is equal to, and the biggest problem people have is they forget that it has to also be by this piece even though it wasn't a fraction, okay? Because it's the same thing, what we do to one side we have to do to the other. So we're doing it to one side, we have to do it to the entire thing. So this one over here is going to become 4x times x plus 1. And then now I just need to multiply this stuff out and simplify it down. So over here, this is going to give me, let's see, 4x squared plus 4x plus 3x plus 3. So that's taking care of that whole thing. Minus 8x is equal to 4x squared plus 4x. So then over here, to simplify this, I've got 4x squared. Let's see, that's going to be 7x minus 8x, so minus x plus 3 is equal to 4x squared plus 4x. So I'm going to move all of this over to the left. So the 4x squareds are going to go away. Negative x minus 4x is going to be negative 5x plus 3 is equal to 0. And then ultimately I'm trying to get x by itself. So subtract 3. So negative 5x is equal to negative 3. Then divide by negative 5, so x is equal to 3 over 5. So a lot of work, but a lot easier than dealing with fractions the whole way down. However, if you really like fractions and you want to do the fraction method, you're more than welcome to do that, but I think this is easier, so this is how I'm going to teach it. All right, let's look at 22. I've got 3 over x minus 2 plus 1 over x plus 2 is equal to 12 over x squared minus 4. So just like I did with problem 14, when I had something that looked like it could be factored, I want to go ahead and factor it. So, any idea what x squared minus 4 factors into? It's a special type. Yep, x plus 2, x minus 2. So that's nice because now it's the same thing as these. So I'm going to do the same thing I did in 18. I'm going to multiply by the denominator of each of the fractions. Since the one on this side is the same as these two combined, I only need to write them once. So I multiply this entire thing by x minus 2 and x plus 2. So for the first one, the 3 over x minus 2, the x minus 2's are going to cancel, so I'm left with 3 times x plus 2. Plus, on the next one, the x plus 2's cancel, so I'm left with 1 times x minus 2, or just x minus 2, is equal to, over here, x plus 2 cancels and x minus 2 cancels, so I'm just left with 12. So then I've got 3x plus 6 plus x minus 2 equals 12. So in one step, I'm going to move the 12 over as well as combine like terms. So that's going to be 4x. And then 6 minus 2 is 4. Minus 12, so it's going to be negative 8. So 4x minus 8. Wait. Right? Well, right, but minus the 12. I have something different on my paper, so I think I did it wrong. We're just going to check. Okay, yeah, I just have it wrong on my paper. All right, so 4x minus 8 equals 0. So I just went ahead and combined like terms and moved the 12 over all in one step to save having to write more. So then 4x equals 8, x equals 2. Any questions about these so far? Okay. All right, so for some reason they split, these have the exact same instructions, but they split them into 2 separate sections of problems. So same instructions, but a new little category here. 26. We've got 4x plus 3 over x plus 1 plus 2 over x is equal to 1 times x squared plus x. All right, so again, I want to see if I can factor this piece over here. And so I can just take an x out, which gives me x times x plus 1, which works out nicely because now I have the same thing that I have over here. So multiply the entire thing by x times x plus 1. So for the first one, the x plus 1s would cancel, so I'm going to have x times 4x plus 3. And if you wanted to go ahead and multiply that through while you're going, that's fine too. I'm just writing out the steps. So if you go back, you can see what we did. On the next piece, the 2 over x, the x's are going to cancel, so we're going to have 2 times x plus 1. And then on the last one, x and x plus 1, they both cancel, so I'm just left with 1. So then I've got 4x squared plus 3x plus 2x plus 2 equals 1. So then going to combine, I'm going to move this 1 over as well. So 4x squared plus 5x plus 1 equals 0. So now I need to factor. So what does this factor into? Or what does the middle need to be split, I guess, into?
1 and 1. 4x plus 1 and x plus 1.
Oh, okay. Yes. So for the middle step, that is what it is. So 4x squared plus 4x plus x plus 1, which then we take out the 4x. We're left with x plus 1. Take out a 1. We're left with x plus 1. So then 4x plus 1 times x plus 1, as you said. So then now we set each of these pieces equal to 0 to solve. So 4x plus 1 equals 0 and x plus 1 equals 0. So 4x equals -1 or x equals -1/4. And then over here, x equals -1. Now, what we didn't have to do with the last one, but what we need to do with this one is we need to make sure that none of our solutions would cause a problem. So basically combining the first thing we did and then what we just did. So if I plug in -1/4, none of these denominators end up being 0. So that one's fine. But if I plug in -1 up here, -1 plus 1 is 0. I have a 0 in the denominator. So this one is not going to work because it's going to cause it to be undefined. So I can't use that one. Okay. Do we see that? Sort of, maybe. So -1/4 is fine because it doesn't cause the denominator to be 0. But -1 would cause this denominator to be 0, which is a problem. And it would actually end up causing this one to be 0 as well, because -1 squared would be +1 plus -1, so that would be 1 minus 1, which would be 0, which would be a problem. So this causes it to be undefined. So the only one that actually works is -1/4. And it is potentially possible that none of the solutions you get may actually work. Okay, so you may get a solution that causes an issue as well, like another solution that causes an issue, and then none of them work. So we always have to check them and make sure we know what's happening. So let's do 28. -x over x plus 1 minus 1 over x minus 1 equals -2 over x squared minus 1. So what does this denominator over here factor into? It's a special type. So what does it factor into? Yep, x plus 1, x minus 1. So then I can multiply the whole thing by x plus 1 and x minus 1. So with the first fraction, the x plus 1s are going to cancel. So that's going to leave us with negative x times x minus 1. Minus, on the second one, the x minus 1s are going to cancel. So we're going to be left with x plus 1. So notice that this minus sign here needs to go to both pieces in here. So I'm going to leave it in parentheses. Okay, so it's going to be minus x minus 1. So if you write it already like out of the parentheses, you just need to make sure you get the sign right, or you'll end up with it being wrong. And then the last one, both things cancel, so I'm just left with negative 2. So I'm going to have negative x squared plus x minus 1 equals negative 2. So when I combine things, I end up with negative x squared. The x's cancel, so then minus 1 plus 2, so plus 1 equals 0. And then we can just solve this one on out. We don't need to factor it in or anything. So we're going to have negative x squared is equal to negative 1. X squared is equal to 1. Then when I take the square root of 1 is just 1, but we got to remember it's plus or minus. So plus or minus 1. So when I go to do this, I want to, again, look and make sure that nothing is causing a problem. So if I plug in positive 1, I have 1 plus 1, so that's fine. 1 minus 1, that's going to be a problem. And over here, 1 squared minus 1, that's going to also be a problem. So the positive 1 doesn't work, okay? So the negative 1, if I plug that in, negative 1 plus 1, that gives me 0. So now I know that both of those are going to be a problem. So this solution, if you remember back to when we did the stuff with sets, basically that means it's the empty set. There's no solution to this problem. So you could either do that or write no solution or something like that. I know it feels kind of pointless to do all of it and then there to not actually be a solution. But, you know, such is life, I guess. And don't think with like this whole section of problems that like they're all gonna have like a situation like that. Like just because the two that we did had something that didn't work doesn't mean every problem in this section will. It just means you need to check and make sure. All right, do we feel like we need to see another one or are we okay? Okay, so what I'm gonna do is that's kind of like the halfway point in this section. So I'm gonna stop there. So one, you'll have some time to work today. And then basically what we'll do is we will test up through this part on Friday, and then next Monday, I guess, we will finish this section. So, and then that will be just on a, like, basically whatever's left of chapter 1, we'll have a quiz, like, pretty near the beginning of next quarter for that. So, up through this point, your problems are 13, 17, 21, and 25. So I'm not giving you a lot, but, you know, as always, if you feel like you still don't get it or something, I would recommend you pick a couple more odd ones within that to do, but that should be pretty sufficient for right now.